The Bisty Wilderness is just that, a true wilderness area. It's been forming for 95 million years, so we encourage people to exercise caution when they're out there. The cracked eggs, the other geologic features, the pedestal rocks are not terribly fragile, but we discourage people from climbing on them and things like that. 95 million years is a long time to wait for more of these to be formed and be exposed. While you're in the wilderness, there are no roads, there are no trails, it's foot travel only, and you can kind of just wander around out there. So we encourage people to be prepared, bring food, bring water, be prepared to stay a little longer than you thought you might. A GPS or a phone app that can track you with the GPS is highly encouraged so that you can keep track of where you are, and then if you find something that you want to revisit, you can mark it and find your way back to it easily. Please do not remove anything from the wilderness. This includes petrified wood, any fossils, any unique rocks that may be exposed on the surface that would look good on your shelf at home. I'm a geologist, I'm a rock hound myself. I get the temptation to do that, but if you're outside that wilderness area, there's a ton of BLM land that has a lot of good petrified wood and other unique rocks that you're free to take home. So if you have any questions about the wilderness, about what you can do outside the wilderness versus inside the wilderness, please contact us at our office here in Farmington. We can answer any questions you have and give you advice on anything. So our number is 505-564-7600. Hello, my name is Chris Wenman. I'm a geologist with the Bureau of Land Management here in Farmington, New Mexico. We're here today to talk a little bit about the Bisty Badlands, the geologic setting of those badlands, and specifically the cracked eggs formation that brings a lot of people to visit these badlands. So the San Juan Basin is a roughly circular, bowl-like type of depression. It covers approximately 22,000 square miles across the Four Corners area. Predominantly, the San Juan Basin sits in northwest New Mexico, where we are now, as well as up into southern and southwest Colorado, and it also bleeds over into Utah and northeast Arizona as well. The San Juan Basin was formed in its current configuration about 65 million years ago during what's called the Laramide orogeny. This was a mountain building event that resulted from tectonic plate movement on what is now the western margin of the continental United States. So this basin, after it was formed by the Laramide orogeny, has been getting filled up with thousands and thousands of feet of sediment. Currently, there's over 14,000 feet of sedimentary rocks filling the San Juan Basin. You can think of these as layers of a cake that dip inwards from structural highlands on all sides of the basin. The structural highlands around the basin include the Sleeping Ute Mountain and La Plata Mountains to the north, the Nacimiento Mountains to the east near Cuba, New Mexico, the Ignacio Monocline, and the Zunite Uplift near Gallup and Grants, New Mexico. And on the west side, the basin is bounded by the Carrizo and Chusca Mountains. The sedimentary rocks that have filled the San Juan Basin range in age from 570 million years old to 2 million years old. The most well-known rock formations in the San Juan Basin were deposited in the late Cretaceous, which began about 95 million years ago. These rocks have the highest mineral potential in the basin, so they contain things like oil, natural gas, and coal, and thus they've been studied probably the most widely out of any rocks in the basin. In the late Cretaceous, starting about 95 million years ago, present-day New Mexico, along with most of the western United States from the Gulf of Mexico up into Canada, were covered by a shallow seaway that was known as the Western Interior Seaway. This seaway was present from 95 million years until about 65 million years ago when it receded for the last time. Included in the Cretaceous stratigraphy of the San Juan Basin are the Kirtland and Fruitland formations. The Kirtland and Fruitland make up some of the unique geologic features that we see within the Bisty Wilderness, such as the Badlands Hills and a lot of the other unique erosional features. Braided streams over millions of years have carved the Badlands Hills from the Kirtland and Fruitland formation, exposing them so that we can see them within the Bisty Wilderness area today. The Kirtland and Fruitland formations, which were named for outcrops that were originally studied along the San Juan River near their namesake towns, are both exposed within the 45,000 acre Bisty Wilderness area. The Fruitland Formation, which is the lower lying older formation, is present on the west side where the overlying Kirtland Formation has been eroded and removed. The Kirtland Formation is recognized by its orange and pink shales, which were oxidized and got their bright colors from fires burning underground within the coal seams. The Fruitland Formation consists mainly of interbedded mudstones, coals, sandstones, and shales. Both the Kirtland and Fruitland formations that are exposed within the Bisti Wilderness contain remnants from the Cretaceous period. These include giant petrified logs, which would have been from ancient cypress trees that were buried quickly and preserved. They also include invertebrate and vertebrate fossils. Vertebrate fossils excavated from the Bisti Wilderness include the Bisti beast, which was a tyrannosaur, and a baby pentaceratops, the first juvenile of its kind to be excavated. There are also unique geologic features or erosional features present that bring a lot of people to the wilderness. These include hoodoos, pedestal rocks, and probably most famously, the Cracked Eggs Formation. The Cracked Eggs are alien-looking red and tan-colored sandstone masses laying on the desert floor. These were originally formed over 65 million years ago as concretions. Concretions are round or oblong deposits formed by mineral precipitation around shell fragments or pebbles in soft sediments. As a concretion forms and is buried over time, the soft sediments surrounding it are deformed. These deformed layers can often be preserved if they have the right burial conditions. In the Cracked Eggs, we see preservation of these layers, also known as bedding planes, which help to give them their alien appearance. So, why do these eggs look cracked? The cracked look of the eggs was caused by a process called differential weathering. The concretions were surrounded by multiple layers of soft mudstone and hard sandstone. The soft mudstone is more easily removed by wind and water erosion, leaving behind the harder sandstone layers, creating gaps or cracks in the rock layers where the mudstone once was. The remaining sandstone is still affected by weathering, although it's more difficult to remove. Part of the alien appearance is the different ways that the hard sandstone is being eroded by wind and water to this day. So how do the cracked eggs get their bright red color? The most likely explanation is the presence of hematite, an iron oxide mineral that will rust when it is exposed to air. I'd speculate that there was an abundance of iron in the water when these were deposited originally. When the concretions formed and they were covered by soft sediments, the hematite would have precipitated out of the water around the concretion and between the bedding planes of the sandstone and mudstone layers that surrounded it. After the concretions and the surrounding sediments were exposed by erosion and layers of soft mudstone were eroded away, the rusty red hematite sitting between the bedding planes within the cracked eggs was exposed and mixes with the buff-colored sandstone that you can see along the bedding planes themselves. This helps to give the worm-like patterns that we see on the eggs when we look at them today. So a big question is why the cracked eggs formed where they are and why do we see them today? I can only speculate on this, but it's possible that there happened to be a concentration of shell fragments or pebbles in an ancient channel 65 million years ago, or a shallow marine environment that had iron-rich waters that were favorable to create concretions. As these concretions were buried and the soft sediments around them were deformed, rapid burial would have had to occur over top in order to preserve these. After 65 million years or more of erosion, I think we just happen to see the cracked eggs today in a spot where mudstone was eroded out from around them and we have the hard sandstone remaining. Some of the other erosional features in the Bisti, such as the hoodoos, the pedestal rocks, and even the Badlands hills themselves, were formed by a lot of the same erosive differential weathering processes that created the cracked eggs. It's a testament to the randomness of the geologic processes sometimes that the cracked eggs are present where they are, but are not present in other areas of the basin or in other areas across the western U.S.